directly underneath the big box because this is so little, it's not going to make a significant difference with how it moves.
Okay.
You follow?
Kind of. So where is resistance?
It's directly along
Yeah.
this line.
Oh, it's not like a pinpoint? Because
Wait a second. I was thinking we were doing a different motion. That's with the resistance? I'm so sorry. Yeah, it is directly in line with this. So the resistance specifically will be right here, but it could be along any point of this, because when you look at a picture, you want to organize it so that you have like a straight line, whether it's the axis, force, and resistance, or whatever they are. You want them along a straight line, whether it's vertical or horizontal. You don't want like one up here, one down here, and then one here. Like it's where, like if you were to draw a straight line, where would they intersect? That makes sense?
Mm-hmm.
Okay. So in this case, the point of the center of gravity is all along this line.
It's just down that line.
It's just down this line. So depending on where the other things we find will determine where it crosses.
Okay.
Does that make sense? Okay, so so with an external rotation, what muscles are working? We would know it's your external rotators, but what's a specific muscle that does external rotation?
Posterior delta?
Mm-hmm. Yep. Where does that insert?
On your humerus.
It is the deltoid tuberosity, right? So that would be maybe here. So again, we draw that line. So that's where your point of force would be. We have our resistance. Now, where's our axis? What are we rotating
I
around?
feel like it's our shoulder, but I don't know if that's right.
Okay, well when we discuss things about rotation, we look at, because it's in the transverse plane, right?
Yeah.
So in that case, the axis is longitudinal.
But it's still gonna go through your shoulder joint, right?
So it will go through your shoulder joint, but the axis is running in this direction. So therefore, the axis is actually along your humerus.
So great, so is it, but I never understand like which side of the resistance is it gonna be? That's what I get
So when it
confused on.
comes to a rotational movement, axis is always in the middle. It's always between the force and the resistance in a rotational movement.
Okay.
Because in order
Yeah.
for something to rotate, that's where the axis has to be.
So if his arm is down though, when he's rotating it,
Yeah, that's where
Is
I'm
that a
slightly
different axis?
confused. Cause I thought we were rotating this way.
We are.
yeah.
So, but longitudinal goes this way. So how does it go this way through your humerus?
Because every motion you have to bring back
Yeah,
to
you do.
anatomical.
So it's this way. So it's going this way through your humerus. Okay, that makes more sense. Okay.
What was?
I was just wondering if you had it like rotating like that, your axis would change, right? Because it's not the same as. Because you're still like rotating here, I guess.
Yeah.
But you're not rotating through your elbow, so isn't it the same?
That one would be a hard one because I don't know where you would define where your center of gravity was. Because your center of gravity would have to go like straight through. Your force would be where your rotating, like where the muscle inserts.
On like quizzes and tests though, does he ask like name what, like where this point would be?
No,
Or is it just like draw kind of?
It's draw. So he'll give you a picture like this and he'll have you pinpoint where each spot is on the picture.
Okay.
Okay. So what What type of a class labor system is this?
First class.
Good. So rotation is always first class. Always. Okay. Did he do the calf raises?
Mm-hmm.
Yeah. Does everyone understand that one? Do we want to go over that one?
Can we go over that one?
Okay.
Because it confuses me when he said a segment pivoting on a surface stays in contact with the surface.
Yes.
And I'm kind of confused at what that means.
Okay, so in this picture, here's the ankle, and there are the toes. So we have our toes here, and your metatarsals, and your calcaneus. That makes sense?
Mm-hmm.
Okay. So in this case, what did he say? What were you?
The segment pivoting on a surface stays in contact with the surface. Something to do with that.
Okay, so that's what's determining your axis.
Mm-hmm.
So that's why your axis in this point is what stays in contact with the surface.
So is it your toes?
It is your toes. So that's your axis.
So is it the ends of the toes or like right as your
So it's like the balls of your feet.
Okay.
So because your toes are here, and then
Okay.
you're standing up on your toes. So it's like these are the edges of your toes, and then that's the phalangeal metacarpal joint. Okay. Okay. So we know our axis. Where is the resistance? Center of gravity, right?
It's near your ankle, isn't it?
Correct. Why?
'Cause it's wanting to push you down that direction. Your whole body is.
Good. Because if you think about all of the weight that's in this picture, the majority of it will be directly going down with your whole body weight, right? Because the ratio, if you look at the ratio between the whole body and then your toes are pretty much nothing compared to your body. So there's your resistance. How about the force?
Calcaneus.
Why is that?
Because that's where your plantar flexors insert, or your
Good.
where it's going.
Is it my plantar flexors
So
or
is
my
it-
dorsiflexors that?
So in this case, it's causing dorsiflexion. So, because you have to think if you didn't have a surface, how your weight would be causing you to move.
Oh, okay.
And so if you didn't have the floor to stop you, your heel would go through the floor, and that would be dorsiflexion. So it is your plantar flexors that you're working. So that's your force. So if we bring this down in line, we have our force, our resistance, and then our axis. So what class system is this?
Second.
Good. Okay. Do we feel comfortable with this? Can we move on to the next section, or?
I just have a quick question about this example. He's holding the weight.
Okay.
I don't understand. When he said your axis can move on this example, I just don't see why it would be the scapula that he's pointing to.
So in that case, that deals with, I believe, the angle of resistance. Because the angle of resistance is going to keep each of these joints, I don't know how to say it, like, they're going to be all in a line, and so there's 0 degree of resistance. And so then, because it's all in line with the center, like, because in here with the angle of resistance, there's a note that says the angle of resistance is 0 degrees if the center of gravity of the distal segment lies on a line between the joint and direction of the resistance. So all along that resistance line, there's a 0 degree angle. And so it has to be your scapula that's moving.
Because your shoulder's not.
Because your shoulder's not. Okay. Because that angle of resistance. Because the resistance would be applied to your scapula and nothing else.
Okay.
Because of that 0 degree.
And is that when picture?
He's just holding the weight
one.
down.
Just holding it.
Yeah.
So just so you guys know, it's
So what would it look like if there was a angle of resistance? Does that make sense?
it would just mean that it would be a different part of your bone that's being acted upon.
Instead of just straight on your scapula?
Mm-hmm.
So can you just write up really fast what the different parts are?
Yep, so we have, this is your resistance. Right, is that how?
Yeah, I was just going down.
So
So is that where your wrist is gonna be, or just?
that's this whole line.
Okay, I just knew that we're supposed to draw certain dots in a row. So how would I? Can I just draw a line like that, and that would be fine?
Yep, you can draw the line like that, and you can put the resistance here. So the whole point of looking at each of these is showing the relationship of them to each other, like whether it's the axis first, then force, then resistance, or vice versa, and intermixed.
Okay.
So here is our axis because it's our scapula, and then the force would be your, because it's causing depression, so it'd have to be your elevators, which would have to attach to the top here. So your force is here. Whoops, not an E, an F. So we have our force, then we have our axis, and then we have our resistance. So if you're looking at it in this direction, the line that I was talking about where you have to draw them in a line, that's your force, that's your axis, and that's your resistance. So therefore you know what order they're going in.
Oh, that makes more sense now.
That's what I was talking
It
about
just kind of
before.
clicked.
Because you want to be able to compare them all in one direction. So
I
that you
gotcha. That makes more sense.
okay. That's how you know what class system it is.
Okay.
So what class system is this one?
First.
Good.
So the depressors they insert on the bottom, right, of the scapula.
Yeah.
Okay.
Because when they contract, that would have to pull your scapula down when they
Yeah.
shorten.